Hello, my name is Kyun Hyuk Lee, a bridge specialist in MIDAS IT, and today I'll be in charge of giving a brief introduction of MIDAS CIM. Some of you may be new or familiar with the concept of BIM. So, before we begin our introduction to MIDAS CIM, I would like to briefly talk about the concept of BIM. Bridge Information Modeling, BIM or BRIM, is a core technology that can make analysis, designs, 2D drawings, as well as 4D and 5D models possible from 3D models. Up to today, haven't you been doing BIM without any information interworking between 3D models, 3D drawing works, and analysis and design works? Didn't you all communicate with 2D CAD and use BIM to create only 3D models? The 3D models created through MIDAS CIM can be analyzed and designed by interworking with MIDAS Civil, and 2D drawings can be made by interworking with MIDAS Drafter. It doesn't matter if you are using another BIM solution. MIDAS CIM enables interworking with MIDAS Civil and Drafter through other BIM solutions and IFC-based information sharing. MIDAS CIM proposes a solution that can connect all tasks required for bridge design projects into just one process. We hope that through this introduction, those who know about BIM but are unfamiliar with MIDAS CIM can get some knowledge on the benefits of using MIDAS CIM. So then, let us start with a short video introducing MIDAS CIM. MIDAS CIM is a BIM solution based on the alignments such as road alignments and railway alignments. So, the first thing you need to do when you start modeling is to define the alignment. Alignment is based on the principle of constructing 3D elements using horizontal alignments and vertical alignments. The alignment created in this way is divided to determine the segment where the actual structure will be positioned, and define the structure to be applied to the alignment using the Smart Template feature. First, let's define the PSC beam bridge. You can easily create an assembly unit model by entering the dimensions and spacings required to define the PSC beam bridge. Models created using the Smart Template are created by utilizing the libraries built into the program. This time, we'll create the cable-stayed bridge model of the main span. The cable-stayed bridge model is not a Smart Template feature, so we will show you how to make the model using a combination of pre-made point library units and curve library units. You can see that the model is automatically assembled based on the shape and constraint condition defined when creating the point library unit and curve library unit. Now, we'll create a steel box bridge model to be applied to the approach bridge span. For the steel box bridge model, let us show you the process of modeling it using the text format defined by the user in Excel. First, import the point and curve library unit required to create the steel box bridge model. It is the order of importing the text file that makes up the principle of how to assemble these units. As mentioned before, this text file can be created through Excel. By using Excel, you can configure a calculation template that can define the type, dimension, and constraint conditions of the steel bridge so that the units can be assembled automatically. The advantage of this feature is that once the Excel template is created, you can quickly and easily create similar structures. As defined in the text file, you can see how the assembly unit is created by assembling the library units. Now, we will show you the process of creating the final bridge structure by assigning the three types of bridge models to the alignment. We define the steel box bridge for the approach section, the cable-stayed bridge model for the main span, and the PSC beam bridge for the connecting section between the main span and the approach section. The bridge models are being assigned to the alignment. The program automatically transforms and applies the unit models we made earlier to fit the alignment and span length of the whole bridge. In this way, the bridge model with three different types of unit models is completed. How can we deal with a situation in which we need to change the previously planned bridge type to a different type of bridge? For example, let us show you an example of changing the steel box bridge section to a PSC box bridge section. In fact, when working on a project, bridge types and span lengths often change due to reasons such as problems with surrounding terrains or construction costs. In that case, as you can see, you can use one of the features mentioned earlier to create a unit model to change and apply it to the location that needs to be modified. There is a feature that can deassign structures assigned to the alignment. Therefore, it is easy to replace the existing structure by deassigning it and then reassigning the new structure. You can see that the steel box bridge applied to the approach section has been changed to a PSC box bridge. Now, let me explain how to model tendons using the PSC box girder example. MIDAS CIM provides different features for detailed modeling of anchorages, longitudinal tendons, and transverse tendons. You can define the anchorage using the DB provided in MIDAS CIM, Import the tendon's profile organized in Excel and enter the tendon coordinates. Because there are various functions that can be used according to the user's convenience, you can model the tendons quickly. We will check each section to see if the generated tendons are properly positioned at the desired location. You can see that the anchorage, spiral reinforcement, and longitudinal and transfer tendons are modeled correctly. As you can see, MIDAS CIM's tendon modeling capabilities allow the user to quickly and easily model tendon across multiple PSC sections. Now, we will explain the modeling process of rebar in a PSC box girder. You can select the representative section to model the rebar and use the features provided in MIDAS CIM to easily model the rebar with just a few clicks. As you can see, each function is provided according to the characteristics of the transverse rebar and longitudinal rebar. Once the rebar modeling is completed in the representative section, you can array the model rebar into the desired section. You can see that the rebar modeling has been completed for the entire PSC box girder. In this section, let us talk about the rebar and tendon clash check feature. We will look at an example of clash detection for the diaphragm of a PSC box bridge. As you can see, the diaphragm of the PSC box bridge is subject to a lot of clashes due to the tendon anchorages and complicated rebar arrangements. In MIDAS CIM, you can easily perform clash detection using the clash detection template feature. When you select a member for clash detection and execute the feature or function, the program displays the location where the clash occurred. Here, let me show you how to adjust the rebar spacing to solve the clash problems detected between the tendon anchorage and rebars. As mentioned before, one of the advantages of 3D models is that problems that are difficult to find in 2D drawings can be found and solved in advance. As you can see, the spacing of the rebars has been corrected. So let's run the clash check feature to see whether the clashes has been resolved. You can see that the clash problems have been resolved on the left side where the rebar spacing was corrected. However, the clash problems still remain on the right side where the rebar spacing was not corrected. By using this feature, you can create an optimal reinforcement condition by solving clash-related problems that occur throughout your bridge model. The results of the clash detections can also be reviewed in MIDAS Drafter, making it possible to make 2D drawing reports. Next, we'll look into the quantity calculation process or bill of quantities. Elements created in MIDAS CIM contain information about quantities. We'll show you the process of calculating the bill of quantities of a cable-stayed bridge as an example. The quantity information can be configured by different fields in the work type. And as you can see, each field in the quantity table template is used to define the classification system, order, and units. If you export the quantity calculation information defined in the table to Excel, you can see that the calculations for the actual quantities are organized in the same form as the template defined by MIDAS CIM. In the quantity table template, the quantities of members such as concrete, pavement, cables, and bearings are calculated according to the attribute information previously defined. Let us take a look at the process of automatically updating drawing plans, creating longitudinal and plan view drawings, and fabricating 3D ISO view drawings after modeling and modifying structural 2D drawings from the bridge model previously created. First, let's create a structural 2D drawing using the substructure example. Let us import the substructure library. As you can see, this pre-made library contains not only the structural shape and reinforcing bars, but also information necessary for 2D drawing work. Drawings can be created and edited in a 2D CAD solution called MIDAS Drafter. If you click the Drafter icon in the toolbar of MIDAS CIM, MIDAS Drafter will launch and open with all the information of the model you were working on in MIDAS CIM. Even drawing information can be saved in the library. As you can see, the general views, section views, dimensions, and rebar drawings that were set in advance in the library are also imported to Drafter. Modeling rebars in MIDAS CIM not only allows you to create rebar drawings, but also automatically generate rebar specifications and rebar schedule tables. In MIDAS Drafter, there is a feature that helps create a drawing that shows only some of the model rebars as well as mark dimensions and annotations to create easy-to-view 2D drawings. The first step is to select the rebars you want to show and mark the annotations. When you start annotating each rebar, you will see that the diameters and spacings are automatically displayed because the model rebars contain all the information needed to create the rebar drawings. As you can see, all rebars are actually modeled. Creating drawings in this state not only creates very complex drawings, but also requires multiple drawings. However, if you use this feature, you can represent everything in a single drawing. By saving all the drawing-related information worked in this way as a library files, you can easily share it with team members, so you can build a process that produces the same high-level drawing results. In this step, we'll show you how the drawings in MIDAS Drafter are automatically updated when the 3D model in MIDAS CIM is modified. We'll modify the height of the pier of the previously shown substructure model. The height of the pier was modified using the parameter option. If the height of the pier is modified, the elevation of the foundation will also change automatically. Also, the number and coordinates of the rebars inside the pier are also automatically changed. Let's run Drafter to check this. You can check that all the information we have previously worked on is stored. Modifying the 3D model doesn't mean that the drawings in MIDAS Drafter change immediately. The reason behind this is to allow the user to check the changed content once more and then update it. If you select the drawing sheet you want to change and run the update function, the 2D drawing in MIDAS Drafter will update according to the contents modified in the 3D model in MIDAS CIM. The important part of updating a drawing is that the dimension lines and annotations made previously should also be updated according to the modified shape. MIDAS Drafter is equipped with a feature that automatically changes the dimension lines or annotations based on the coordinates of the structure. Without this feature, it will be difficult to modify the drawing every time the model changes. Now, we will update the rebar drawing. As the modified structure shape is updated, you can see that the number and spacing of rebars are also automatically modified. We have shown you how the section view, ISO view, and rebar drawing were automatically updated. MIDAS CIM automatic drawing update feature makes it easier and faster to modify drawings when the bridge format or dimension changes. This time, we will create a plan view drawing that represents the entire structure. If you define the model on MIDAS CIM as a drawing view, it is automatically created as a plan view in MIDAS Drafter. As it can be seen, Certain views specified in MIDAS CIM have been converted to the drawings in MIDAS Drafter. Defining views as drawings is possible not only in MIDAS CIM but also in MIDAS Drafter. As you can see, you can also create additional sections using the object properties information of the 3D model by selecting the section of the desired section in MIDAS Drafter. You can create drawings of the pylon section, PSC beam section, and PSC box section of the cable stayed bridge model. Now, let us create a longitudinal section view drawing. When the alignment is a straight line, creating a longitudinal section view is not that difficult. However, in the case of a curved alignment as shown in the example model, many will find it difficult to create a longitudinal section view because they will need to change the alignment to a straight line to create a longitudinal section view. In MIDAS CIM, by using curve drawing function, it is easy to create a longitudinal section drawing because it automatically converts the curved alignment into straight alignment. You can see what would have taken an engineer half a day of work can be completed in a matter of minutes. Let me show you the process of making the final longitudinal section view drawing by inputting dimension lines to each sheet made in this way and collecting them in one frame. As mentioned before, the dimension lines defined in this way are very useful because they are automatically corrected when the dimensions of the structure changes. In MIDAS Drafter, the user can specify the thickness of the line and the color of the layer be displayed differently according to the characteristics of the structure. In addition, there is a function that can save the defined forms as templates according to the specific projects. To make the final drawing, place each sheet in its respective frame. Each sheet made this way is not a simple cat line, but a drawing containing information about the structure. Therefore, if you change the scale of the sheet, you can see that dimension lines are also automatically changed to fit the scale. As you can see, even if you scale up the sheet, you can see that it updates automatically without having to readjust the text or dimension lines. Multi-scale drawings with different scales for each sheet have been completed. Now, let me show you the process of creating 2D drawings and marking the coordinates of the ISO views of the cable stayed bridge model shown on the screen. First, define the views to be drawn using the drawing view function. Then, run MIDAS Drafter. In the drawings created, enter the coordinates using the coordinate annotation function. You can see that the coordinates are entered by clicking on the desired location. In addition, MIDAS Drafter provides a function that allows the user to define the annotation style directly. You can also define the text you want and use it by setting the annotation you want. As you can see, we can add elevation coordinates, and we can also define the precision of the coordinates. Once you define and update the annotation style, you can see that it changes to the desired coordinate form. This is a very useful function because you can enter coordinates without any additional computations. Now, we'll explain the process of importing the topographical information of the area where the structure is located. Check whether the bridge location is appropriate, and also show how to use it for animation during different construction stages. When planning bridge structures, it is imperative that topographical and spatial objects as well as existing structures be reviewed. MIDAS CIM provides a feature that can check the surrounding terrain by importing satellite images from Google Earth or vWorld using API. The process you see now is the process of importing the satellite images by actually inputting coordinates using the UTM coordinate system. If you specify the desired area, it will fetch all the information specified by the user. The topographical information also includes elevation information. As you can see, you can visually identify the surrounding conditions of the bridge by bringing up 3D terrain information that fits the project area. This time, we'll explain the process of checking whether the location of the planned bridge is appropriate using the imported topographic information. As you can see, you can check the piers installed on the existing road. In such cases, the user must change the position of the bridge that interferes with the existing road. The position of the pier can be changed by modifying the segment position of the alignment. Since the pier library is linked to the alignment, moving the segment coordinates of this alignment automatically moves the point library unit pier. The substructure, which is a curb library unit, will automatically extend or shrink as the alignment changes. MIDAS CIM has the ability to create construction stage animations using the model structure and topographical information. The animation can be used simply as a video to help users understand the construction stages, or it can be used for the purpose of calculating the quantity of members of each construction stage. The construction simulation function can be configured considering the movement and rotation of members, as well as activation and deactivation of members. This feature allows the user to calculate the cost of operation of construction equipment or construction materials over specific construction stages. Most importantly, all MIDAS CIM users can easily create construction state animations with this feature. Now, we will explain how MIDAS CIM exchanges modeling information with other BIM solutions, such as Revit or Navisworks using IFC. IFC stands for Industry Foundation Classes, which are data formats for exchanging information between different BIM software. Export the substructure example file model up to the rebars in IFC format. At this time, we provide functions that allow the user to make additional settings necessary. Run Revit and import the IFC file created in MIDAS CIM. As you can see, the 3D model of the substructure and the rebar are imported. Check IFC parameters for the structure's shape and IFC parameters for the rebars. You can see that the model and information entered in CIM are all imported correctly into Revit. MIDAS CIM supports integration with MIDAS Civil. Models created in MIDAS CIM can be exported into MIDAS Civil and vice versa. Analysis cases can be defined in MIDAS CIM's analysis mode. To export 3D models to MIDAS Civil, define the element type, element dimension length, self-weight, etc. In analysis mode, you can preview the geometry of the structure to be used in MIDAS Civil. After some additional work such as defining boundary conditions, the created finite element analysis model is exported to MIDAS Civil. As you can see, the 3D solid model with the information has been created into a 1D element model for structural analysis. If detailed analysis is required, input the additional information required for analysis and begin the analysis. Let's check the displacement results of the structures that has been analyzed. Even if you are using a BIM solution other than MIDAS CIM, you can still create a MIDAS Civil analytical model using the method described. So far, this has been the introduction and feature description of MIDAS CIM and Drafter. Lastly, we will end by showing a short interview video of the developers of MIDAS CIM and Drafter. Thank you very much for your time.
CIM CIM 개발을 총괄하고 있는 서충원 그룹장입니다.
드래프터의 기획 총괄을 담당하고 있는 이재형 책임입니다.
2005년부터 마이다스 11을 보급하고 사업을 진행해온 이호정 수석입니다.
기술과 교육을 담당하고 있는 김태호 책임입니다.
외국계 토목 설계 회사에서 구조 설계 6년 정도 했고요. 거기서 BIM 디렉터도 동시에 같이 담당해서 업무를 수행했습니다. 그때 당시에 BIM은 또 지금보다도 더 과도기적인 BIM이었는데요. 설계는 설계대로 하고 도면은 도면대로 그리고 BIM 모델은 3D 모델에 3D 모델대로 따로 하고요. 그래서 사실은 전혀 연관관계가 없는 모델링을 하고 있었던 거죠. 제가 이런 경험들을 많이 하다 보니까 그 모든 게 하나로 연결된 도면 프로그램을 만들고 싶었습니다.
네, 제가 지금 15년 정도 개발을 했는데요. 개발자이기 전에 토목 엔지니어 출신이거든요. 그래서 엔지니어분들이 한마디만 얘기를 해도 전에 그 경험들 때문에 한 10가지, 20가지 막 필요한 기능들이 막 생각이 나는 거예요. 거기에 다시 또 좋은 피드백을 받다 보니까 그런 과정들이 너무 재밌고 신났던 것 같아요.
등기 같은 걸 나가다 보면 여러 가지 대안을 가지고 나가야 되잖아요. 형식별로 경제성 평가를 위해서 수량 체크를 해야 된단 말이에요. 스마트 템플릿 기능을 사용하면 여러 가지 형식이 일괄로 쉽게 만들어집니다. 수량도 바로 나올 수가 있는 거고 해석 파일을 보내는 것도 금방 할 수 있기 때문에 가치가 있고,
기존에 우리 설계자들의 자산이라고 하면 도면과 설계 계산서 또는 시빌 모델 해석 파일들 같은 것들이 있을 텐데요. 그런 것들이 누군가의 하드디스크에 들어가 있다든가 그럼 그 회사의 자산이 아니라 그냥 그 개인의 하드디스크에 있는 자산이 되거든요. CIM을 통해서 라이브러리를 구축하고 모두가 공유한다면 그 회사의 자산이 축적되고 도면이나 해석 모델 같은 것들을 바로바로 생성해낼 수 있는 아주 효율적인 업무 프로세스가 갖추어지게 됩니다.
최근에 고객사들을 만나면은 BIM 어떻게 해야 되냐? 도대체 어떻게 적용해야 되냐? 이런 얘기들을 많이 하시더라고요. 20년 전만 해도 케이블 해석, 수화열 해석, 내진 해석 같은 경우는 정말 전문적으로 그 분야만 했었던 사람들만 가능한 영역이라는 거. 지금은 마이다스 11로 누구나 그 해석을 할 수가 있게 됐어요. 토목 분야 BIM은 CIM으로 누구나 할 수 있는 영역이 될 겁니다.
초당대교랑 사업단에서 지금 BIM 디지털 모델이랑 11 해석 연동을 하는 기술 개발하고 있는 책임자거든요, 제가. 선도 기술을 이끌 수 있는 이제 업체들 위에 대표분들하고도 얘기를 많이 해보면 건설 분야도 이제 자동화가 돼야 된다. 그렇게 되기 위해서는 BIM이라는 기술이 꼭 필요한데 해외 프로젝트를 진행하려고 하면 기본적으로 이 기술은 가지고 있어야 된다. 저희가 또 토목 분야가 선도는 아니거든요. 이 좋은 소프트웨어와 좋은 인프라를 가지고 있는 국가에서 이 기술을 가지고 해외에서 건설 분야를 이끌 수 있는 리더가 여러분들이었으면 좋겠습니다.
앞으로도 저희의 이런 생각들은 변함없이 계속 유지될 겁니다. 어떤 요구사항들을 계속 반영을 할 거고 아마 제가 정말 방문해서 요구사항 듣는 경우도 있을 거예요. 이 정도로 저희가 바로 옆에서 좋은 기능들을 발굴하고 반영할 거기 때문에 앞으로도 기대 많이 해주셔도 좋을 것 같습니다.
11을 통해 엔지니어링의 기준을 만드셨던 것처럼
토목 실무자분들이 중심이 되셔서
다음 기준 역시 CIM을 통해 만들어 가실 거라고
믿고 지원하고 응원하겠습니다.